So here are my solutions for defining real and fake losses. Let's go through the real loss function first. So this takes in the logits or outputs from our discriminator. When we train, there will be one output value for each input image in a batch, and I'm getting that batch size here by calling dout.size of 0. This way I know how many output values I have to look at. Next, I'm creating my ground truth real labels. And I have two cases for defining labels here. One is if I want to implement label smoothing. So if smooth is true, I'm creating a series of 1 labels and multiplying all of those by 0.9. So this creates batch size number of labels that are all 0.9. If smooth is false, I'm leaving off this multiplication parameter and I'm leaving these values as 1. Next, I'm defining my loss criterion, BCE with logits loss. Then I'm applying that to the output of our discriminator and the labels that I created above, our target real labels. And here I'm just squeezing any empty dimensions from the outputs. And that's it. Then this function returns that calculated binary cross entropy loss. Recall that this function is also applying a sigmoid activation function to the dout logits. Okay, great. Then you can see that I'm doing almost the exact same thing in the fake loss function. In fact, this is a little simpler because we don't have a smooth parameter. First, I'm getting the batch size of our output logits. Then I'm creating ground truth fake labels, this time using torch.zeros. Then I'm using my same BCE with logits loss criterion and applying that to our logits and these labels that I created right here. So the big difference is that I'm using torch.zeros here instead of torch.ones, and I'm calculating the loss in the exact same way and returning that calculation. And this is all I need to do to define my real and fake losses. Now, for my optimizers, I'm creating atom optimizers as usual, passing in the parameters for my discriminator and my generator and the learning rate that I specified above. Now, it's important to have these two different optimizers because I'll be training these networks separately. And if you changed around these hyperparameters, I'd be interested to see how your model performs versus mine. Now, training these networks is really the last step in getting a trained generator and generating new fake images, and that's what I'll go over next.